Welcome to the Iferia TechCast, where we bring you all things science, engineering, technology, and innovation. Today we are joined by Vlad Savinov, AI team lead specializing in large language model pre-training, where he manages the complex process of training models with billions of parameters. At 24 years old, he has quickly moved from a university fascination with AI to leading teams that build the distributed training infrastructure behind today's most advanced language models. In this episode, we'll pull back the curtain on what it really takes to train these massive AI systems and the challenges of working at the cutting edge of scale. So, Vlad, welcome to the show. It's a pleasure to have you here today.
Thank you for the warm intro. Yeah, excited to be here.
All right, so let's get in started, Vlad. You are leading an LLM pre-training team at just 24 years old. So your journey into AI started in the university. So what was the specific project or aha moment that hooked you and made you decide to go all in on large language models?
Yeah, that's a great question. I'd say actually the fascination with technology started long before the university. I've been
Hmm.
competing at Olympiads and various math competitions and programming competitions even back at high school.
Wow.
Yeah, and originally at university, I actually started, I think, taking more math courses than programming courses. And during my university years, I've joined the company as a software engineer, actually, and then pivoted to machine learning because of the joint background in computer science and in math. So this is basically my intro. But if we want to select one project, I'd say probably my bachelor thesis, which was on reinforcement learning, which at the time I was really obsessed with, and I still think it's pretty interesting. So it was a project mostly focused on robotic interactions and how to basically schedule autonomously a coordination between multiple like small agents, let's say in a factory in any grid actually, and how to make them reach targets as fast as possible. And I think it was a really nice project to work.
Oh, fantastic. So let's talk about scale. So you work with models that have billions of parameters. For our audience of engineers and students, what's a simple analogy you'd use to describe what a parameter actually is and why having billions of them is both powerful and incredibly challenging?
That's an interesting question, and I think now with this recent boom of large language models, right, and ChatGPT and whatnot, there is a lot of misconception and understanding models as these large black boxes which you can interact with, but you don't really know how they're organized. While in practice, actually, any model is just a collection of numbers. So you can think of a model as just a lot of numbers and some sort of mathematical operations on top of these numbers that tell you how this model is performing the computation, right? It basically just has a lot of additions and multiplications. And a simple analogy that people like to draw here is comparing the model with brains and with neurons in your brain. I'm not really a huge fan of this analogy, but I think it makes things a bit simpler to reason about. And with this analogy, you can think of a parameter as a neuron in your brain, but in reality, a parameter is just a number. So if the model is, let's say, 100 billion parameters, it means there are 100 billion actual numbers, right, inside of this model that running the computation behind.
All right, that was a really powerful analogy. Well explained there. So Vlad, you mentioned that your work involves distributed training infrastructure. So, what does that system actually look like? Is it like a giant orchestra of computers? So, tell us.
Sure. So you have probably heard about GPUs and how NVIDIA is so expensive nowadays,
Yeah,
right? And yeah, everyone being
yeah.
obsessed about the compute. Well, uh, the problem is in order to run these huge models fast, you actually have to be able to run specific mathematical operations very fast, which is a matrix multiplication. Essentially, you take a lot of numbers and you multiply them and add them and so on. And NVIDIA's GPUs is really powerful when it comes to running this computation, but unfortunately, it is very limited, right? So it's like 80 gigabytes or 100 gigabytes, even on the
Mm,
most modern GPUs. You don't have a lot of memory. But if you think
yeah,
about a large model, since it's a lot of numbers, right? A lot of numbers. And there are also a lot of these results, intermediate results coming from computation. They can take several terabytes of data in the process. So, in order for you to essentially manage this really large network, vast majority of numbers, you have to divide these numbers somehow between GPUs. And this is where the distributed training comes into play, because this is essentially a strategy for you to split all these numbers across, you can say, different computers or different GPUs and coordinate the computation, coordinate the training process, so called, between these devices so that the training is efficient and is as fast as possible.
okay, great. So, when you are training, no, when a training run for a massive model is underway, what does your team's war room, quote unquote, looks like?
Um, Yeah. So whenever we want to train a large model, usually the focus is on making the training run as smooth as possible and as fast as possible. Because if you imagine
Yeah.
being a business, you want to deliver the model to your clients in a timely fashion, right? And you want the training
Mm,
to be fast. And for example, in order to train a model, you need a bunch of data. And to select the best data recipe, you have to conduct a lot of experiments. So basically, the more experiments you conduct, probably the higher quality of the final model you would get. And essentially, our job is to make the experiments and to make the final run as fast as possible. So the final quality is as good as we can get for the limited amount of time that we have before actually releasing the model.
okay, that's really insightful. So you've spent years, teaching algorithms to undergraduates. How has teaching complex concepts to students made you a better engineer and team lead when explaining technical challenges to your own team or stakeholders?
Yeah, that's a great question. Thanks for talking about teaching, because I really find teaching fascinating. It's a hobby of mine that actually goes from my own high school and my own undergraduate studies, where we had a lot of um, teachers and professors who were kind of volunteering for free to
Hmm.
teach because they went through the same program before, and this ecosystem of passing knowledge back that you received previously, I think, is really powerful. But yeah, when it comes to teaching undergrads, I think um, it really makes you kind of redigest the concepts that are familiar to you, right? Some things that you work on daily, but maybe you do not think deeply about them anymore because this is just your routine. And whenever you have to explain them, actually turns out there are a lot of blind spots and a lot of things that you cannot explain in a nice fashion. So I think it really helps you to rebuild the fundamentals, and fundamentals are really important, I think, in our job and in every job. And yeah, obviously it makes you understand where the struggles and where the hardships in these concepts that you're working with come from, and where are the easiest parts that maybe you don't have to think about that deeply. And this is basically like putting books on a shelf, so this book is really complex and you move it to a shelf where you constantly revisit it so that you don't forget the ideas in that book.
All right. So, Vlad, the open source movement in AI is really huge. From your vantage point inside the industry, so why would a company spend millions to train a model and then just give it away for free? So, what's the real strategic play there?
Um, yeah, have you heard about DeepSeek,
Yeah,
the
I use
DeepSeek model?
DeepSeek.
Yeah. So I think this is one of the main points, right? If I were to ask you, let's say 3 years ago, have you heard about ChatGPT? You would probably say yes, but when asking like, do you use DeepSeek? You'd say, yeah, I don't know this company, right? And now everyone knows
Yeah,
what the DeepSeek is, and this is
yeah.
obviously very, very powerful and very cool for the company, because if your name is associated with breakthroughs, if your name is associated with something that others cannot achieve maybe that easily, right? Or at least it
Mm,
seems that it is really hard to achieve, and you attract talent, you attract open source community, and you attract a lot of real wonderful and passionate people who are excited to build on top of the things that you share. And for example, DeepSeek, since we started with it, shared some technology openly around a year ago, including the model, right? And the community actually did a really nice job of improving this technology. And there has been several new models built on top of DeepSeek, introducing even new technologies. There has been a lot of patches and modifications into their libraries. So they are, I think, also benefiting hugely from the open release, and the way
mm.
for you to be able to reuse what community introduces on top of the technology that you share, alongside with obviously the talent that you're able to attract with these releases. I think that's really.
All right, that was very insightful. A really great response there, Vlad. So, for the many professionals considering a pivot into AI, so what is, in your opinion, the biggest misconception that they have about the day-to-day work?
I'd say that there are several things that can go wrong if you just try to get into AI. The first thing is when you hear about AI, you think about like, the great potential and the ability to automate a lot of things, right? Like, let's not use humans here. Let's use AI instead of this. Let's make this process not manual, but rather automatic. We would only pay $1 for ChatGPT API. But in practice, there are a lot of blind spots, I think, and a lot of things that even the most advanced models that are capable of solving like PhD level math questions, they're still failing at sometimes at simple things, right? And making the process of automating something reliable is a huge challenge, I think. And there are lots of companies that try to build products on top of these base models. And usually it is not just wrapping the model with an API call, right? It is something more advanced. It's coming up with the benchmarks, with the evals for your specific feature. It is collecting the data, cleaning the data, then collecting the data again and again, and cleaning it again and again. And yeah, I think the huge misconception is everything just works kind of out of the box, and the models are so powerful that you can just easily use them. But in practice, I think there's still a lot of work you have to put into actually make a lot of like useful things for businesses or for general applications.
All right. So I'd like to ask you a question about your job. So what is the most common or perhaps frustrating bug or failure mode you encounter in a large scale training job? So is it a data issue, a hardware glitch, or something else entirely?
Um, yeah, I would say data issues and hardware glitches do happen, but this is just a part of the job. One of the, I think, I'm not gonna say frustrating moments, but definitely a learning experience. Let's frame it this way: is the possibility for your training run to diverge. Whenever you train a model,
Mm,
you have several metrics, right, that you track, usually called to loss function or a performance on benchmarks. It's like basically how well your model performs, and you usually expect that throughout training, this loss function is going down, which means that your training is stable, the model is acquiring kind of new knowledge and going through the documents. But sometimes your model can diverge when the loss suddenly goes up, and it means that your model is essentially garbage. You cannot use it; it's not useful, and you have to start over. Sometimes you can just roll back and continue from the past checkpoint. But what comes with the scale is the hardships of debugging this sort of divergences, because sometimes you have a lot of checks, a lot of quality checks in place, where you train a smaller model, you train it for several days, and everything works fine, and you check a lot of things. But then you launch a final production run, and it just diverges. And with these moments, it's really hard to go into the woods and understand what went wrong, but I think we handled and learned how to handle these problems successfully, although obviously this is a very hard thing to get, and this is something that definitely scale introduces when it comes into play.
all right, all right. So, looking at the current landscape, what's one recent technical breakthrough in training efficiency or architecture that genuinely excited you and your team?
Say a lower precision training. So in the beginning, we talked about models being a collection of numbers, right? But the reality is these numbers can be different, and the operations we run on them can be different. Usually a number is just a float 32 or bf16, which means that um, one number takes 4 bytes of memory or 2 bytes, right? But over the past, I'd say year and a half, a lot of models came out that use a thing called lower precision training, where you can train a model using only 1 byte for these numbers, for the weights. And it's actually a really challenging thing to get right, because whenever you start operating with these kind of small numbers, with lower precision numbers, it means that you sacrifice some quality and you leave some quality on the table. But instead, you gain a lot of performance, actually, because the GPUs are able to multiply these numbers much faster. So you can actually speed up your training by 2 times sometimes, so by 50% by using these lower precision numbers. And I'd say models that are released with and are trained with lower precision is a really cool technology, because it means that we can train these huge models and get these huge systems basically with 40% less time spent and less money. So yeah, I'm pretty excited to see where this lower precision training would go next in the future.
Oh, fantastic. So, Vlad, for a student listening who wants to work on these kinds of systems in the future, so what is one foundational skill outside of pure math that would make them stand out when applying for a role on a team like yours?
I'd say build projects. I just say build a lot of things and be curious. Be curious about the field. Be curious about the papers, the new technology, and try to apply it in practice. Obviously, the knowledge from the papers is very important, but there are so many papers nowadays. You can scroll through thousands of them every single day. And to be able to actually make ideas work, I think this is a really hard skill to get. So being able to transform an idea into working technology, being able to get a paper and make this paper actually work and debug everything that comes along with it, I'd say, yeah, definitely try to push towards that direction, try to build stuff, play with stuff. And I'm really happy that there are a lot of open source communities nowadays. Like, for example, there's a GPU or CUDA mode on Discord, and a lot of actually big uh, companies have Discord channels where you can go, and even without access to GPUs, without having money or having the resources to buy one, you can actually go and try to write some code that would be launched on these modern GPUs, like joint computations, hackathons. And yeah, I think by just building a lot of cool stuff, you can actually get really good at implementing the ideas.
All right. Thanks for sharing. Very insightful. So there's a lot of public debate about AI's future. So as someone building these systems from the ground up, so what is a concern you think is overblown, and what is a potential risk we should be paying more attention to?
There is actually a really strong debate nowadays in the community. Usually, this debate is summarized as accelerate versus like some safety concerns, right? And
Yeah.
acceleration is basically scaling the training runs even further, because we've seen over the past 5 years that by scaling a model from the one that can be trained on your phone to the model that is trained on tens of thousands of GPUs, you're able to get this amazing performance. You're able to get the model that can solve PhD level problems and can help you with a lot of things. And obviously, there are a lot of people who say that you should scale even further. And there are voices saying that if the scaling doesn't work, probably you're scaling the wrong thing. And yeah, for me, I definitely agree with this. And I think that we can scale further and we can scale other recipes. We can build even more powerful models by scaling some components of it. Obviously, there's a lot of research on how to make the same advancements on small scales and with small models, with on-device tech, right? But still, I think there's a lot of room for improvement. But at the same time, I think we should not ignore the safety concerns. And obviously, OpenAI and Anthropic and a lot of companies are building the tools and building the frameworks that try to explore how dangerous the models that we get and that we use are, and being able to scale with this in mind, right, with the safety concerns in mind, I think it is important. There are obviously people that label this as a doomsday, like a Terminator scenario, that the model would, like, I don't know, go and be sentient and would be like, can reason about things and whatnot, that we shouldn't be afraid of it. And yeah, while I do get that some of these concerns definitely sound like a sci-fi movie, and something that would not happen, I still think it is important to be cautious and at least to keep this idea in mind, that we have to at least take a look at the safety risks, at how these models are well suited for when children use them, for biochemical use, right? And for that. And obviously, there are people who ignore this completely, people who focus on this a lot and work only on that. And I prefer to stay kind of in the middle. And yeah, I think it is important.
All right. So leading a technical team at a young age uh, must come with its own unique challenges. So, what has been your biggest lesson in managing experienced engineers and aligning a team on a highly complex long-term technical goal?
I would say just be open to hear from others and be open for feedback and be mindful about how this present tech and working on really complex technologies with tight deadlines make people think and feel because still in the end there are people, right, who are working with you and you're working with human beings who can be affected by unsuccessful releases, who can be affected by the features that do not work. And yeah, I think being mindful about the workload, being mindful about what people expect from you and expect from the team, from the technology that you're working on is very important. And actually, it is really hard to get right, I think, in the first place, to be able to not push through every time, but still push through when you feel like this is something that is needed to be done. So probably I'd say that even though the hard skills, so-called, right, being able to debug the code and being able to see the technical issues are very important, especially on this scale. The soft skills of how to speak with people, how to understand maybe like the general vibe, let's say, is equally important.
All right. So, Vlad, part of the theme of this podcast is centered around innovation. So, for that reason, I like to reserve one question on innovation for every guest that I have a conversation with. So, in your work, building the foundational infrastructure that powers the next generation of AI. So, what does the word innovation truly mean to you?
I'd say innovation is making things work when no one has made so before. So being able to actually make something that runs as expected and as you wanted it to work for the first time, right? And this is the hardest challenge because sometimes in theory something is very hard, very easy to get right, and something is very obvious, and it feels like you can just go and do this with 2 lines of code or with like a few months of work, but solving through all these technicalities and through the small things that come into play when you actually apply the idea you had in mind to the real world. I think this is really hard, and seeing this through and finishing your ideas and making them work, I think this is a real innovation.
Fantastic. So finally, Vlad, for our listeners who wants to follow your work or learn more about the technical side of LLMs, so what's the best place for them to go connect with you online?
Yeah, please go to my LinkedIn page and shoot me a message if you wanna learn more, wanna hear about the resources to dive deeper.
Oh, fantastic. So I'll also add a link to your LinkedIn profile on the show notes so that listeners can easily get to contact you. So, Vlad, it's been a really insightful conversation with you, and I am really excited and honored to have you on this podcast today.
Thank you so much for taking the time.